Good afternoon. My name is Karim Sapag from Argentina. I'm going to talk about work, a methodology to obtain microporous volume in nanoporous solids based on the DUBININ methods. The nanoporous solids are classified following the UPAC in micropores, mesopores, and macropores. For the high specific surface area and porosity are very interesting materials and applications like absorption and catalysis. The textural properties of this material, like specific surface area, pore volumes, and pore size distribution, are obtained from different methods and models from the experimental isotherms, like nitrogen absorption performed at 77 Kelvin. The different models are, for example, the classical models to obtain a specific surface area, Langmuir and BT, or pore volumes, DUBININ, alpha, and diploid and Garrich, and pore size distribution, GH, and BBAs. The models using computational calculations are density functional theory and Monte Carlo simulation. And this work will propose new methods, DRT, that combines the DUBININ-Roscoe method and the T, where T is the thickness of the adsorbed layer on the surface. By this method, we can obtain the specific surface area of the mesoporous region and the porous volumes of the one material with typical pores in microporous and mesoporous regions. This method is based in DUBININ Catholic proposal, where they say that the isotherm of a given micropore mesoporous materials is the linear combination of the individual isotherms of the microporous and the mesoporous contribution. For example, this type of microporous and mesoporous isotherm we can put as a combination by individual microporous isotherms and individual mesopore isotherm. We can put this combination by the equation. This is the micropore volume. This is the adsorbed volume of the microporous and mesoporous material. And here we can put the specific surface area of the mesoporous region in product with the thickness of the layer, the absorption layer. We show the application of these methods by some examples using CMK8, the ASBA 15, and filared plate. This is a carbon mesoporous material. This is SB-kin, is silica with aluminum mesoporous material, and this is a micro and mesoporous material from clays. For example, in this case, we choose the aluminum ASBA 15. We plot up to 0.4 in relative pressure the original absorption isotherm, and choose different specific surface area mesoporous region up to obtain an isotherm type 1. In this case, we can obtain a typical microporous isotherms. In this case, following this equation, choosing the specific surface area mesoporous region and calculation the thickness of absorbed layer from standard material, we can obtain the individual isotherm of the micropore region. From this, and using the DUBININ-Radulescu, we can obtain the micropore volume. For example, in this plot, we compare the original isotherm and the modified isotherm and the difference between them in the value of micropore volume. For the other samples, like CMK8 and Pilares clay, we can see in these plots the difference between the values of micropores volume obtained by the different methods. In this graph, we can compare the micropores volumes obtained for different methods for the different chosen samples. In this case, the blue, and in all the case, the blue is the DUBININ-Radulescu and red is DRT. We can see here the great difference within classical DUBININ-Radulescu and the new method DRT. As conclusion, we can say that the proposed methodology is easily applicable in any micro mesoporous material to determine the S-meso and microporous volume. To use the methodology, it is only necessary to know the T as function of relative pressure that is obtained from a standard reference isotherm representing the study sample. Thank you very much.